React is the most popular front-end framework, and that's for a reason. Besides being founded by one of the largest companies on the planet, it's also built around a few key concepts that make it easier than ever to create robust applications. That said, it's not without pitfalls. It's easy to write inefficient code in React, with useless re-renders being the common enemy. Usually, you start from a simple application and gradually build features on top of it. At first, the application is small enough to make the inefficiencies unnoticeable, but as the complexity grows, so does the component hierarchy, and thus the number of re-renders. Then, once the application speed becomes unbearable, you start profiling and optimizing the problematic areas. In this video, we're going to discuss the optimization process for lists, which are notorious sources of performance problems in React. Most of these techniques apply to both React and React Native applications. We'll start from a problematic example and gradually discuss the process of identifying and solving the different issues. So the example is a simple list of selectable items. If you click on an item, it gets selected. If you click again on them, they get unselected. Now the problem is that the list is visibly laggy. If we click, we have about half a second before the item gets selected, and our goal is to make this list feel snappy. If you are interested in the code, you can find the complete code sandbox link in the video description. So if you want to practice a bit, you can also go on the link and try to solve as many problems as you can before we go ahead. So without further ado, let's dive right into our example. Before getting started, let's first see what this example does. So we first create the array of the items that we are going to use later to be displayed in the list. Then we have an array containing the selected items. So once we select an item, it will be added to this array. We have a function to toggle the selected and unselected items. Then we have a list of elements. And finally, we have the list item, which contains this expensive operation right here. In this case, this method is used to simulate a slow rendering, but in real-world applications, usually you don't have a single expensive method, but rather you have an item that is very expensive to render for other reasons. Perhaps they have a lot of children or a complex hierarchy behind it. And so, again, this is just a simulation, but the techniques we are going to discuss in this video will be helpful also for real-world scenarios. Okay, so this is pretty much it for the example. And the first thing we notice is that in the console, there's a warning. Each child in a list should have a unique key prop. Of course, this is a very common beginner mistake, and that is caused by this list item here. So we are creating a list of items and we are not passing a key to these items. So as you may already know, the key prop is critical for dynamic lists to work correctly in React, as it helps the framework identify which items have changed, are added, or removed. A common beginner's anti-pattern is to use the index as key to solve this problem. So as we know, the map function also accepts a second parameter that we can use to access the index of the current element. So if we place key here, and we place the index as key, the warning should disappear. As you can see, the example is still kind of working and we don't have the warning anymore because we provided an explicit key. Now, despite working for simple use cases, this approach leads to multiple unexpected behaviors when the list is dynamic, with items being added or removed. For example, if you delete an item from the middle of the list, then all list items located after that item will have a different key, because we would have shifted all the items by one, and so the key of all subsequent items will get a different index and therefore a different key. If you're interested about the potential pitfalls, I highly suggest this article. I'm going to link it in the video description. It goes in great length to explain the potential pitfalls of using the index as key. Key takeaway here is don't use the index as key as much as you can. Now, in general, If you have data coming from a backend, you will have some kind of unique identifier you can use. In this case, we do have the ID property conveniently for our items. So what we can do is remove in the index and then use item.id. And this solves our problem. If for whatever reason you don't have an ID in your items, and that might happen, for example, if the items are generated locally, in that case you might not have an ID out of the box. One thing you can use is generating the client-side IDs with a library like NanoID, which generates short, fast, and very nice unique identifiers you can use at creation time inside your items, and then use those identifier inside the list item. Okay, so adding the key solves the previous warning, but we still have a significant lag when selecting the items. Now that we solved the key warning, we are ready to tackle the performance problem. At this stage, using a profiler can help us track down the slow areas and therefore guide our optimization. So that's what we are going to do. Now, before getting started, we'll have to open the example in a new window by clicking this button right here so that we can use the profiler freely. When working with React, there are two main profilers you can use. The first one is the browser built-in performance tab, for example in Chrome, and the second one is the profiler inside the React DevTools extension. Both of them are useful in different scenarios. From my experience, the React DevTools profiler is a good starting point, as it gives you a component-aware performance representation, which is helpful to track down the specific components that are causing problems. Whereas the browser built-in performance tab, the profiler, works at a lower level, and it's mostly helpful in those cases where the performance problems are not directly related to a component, for example due to an external slow method or a Redux reducer, just to give you a few examples. For this reason, we are going to start with the React DevTools profiler. So make sure to have the extension installed. Then you can access the profiler tool from Chrome DevTools profiler. But before starting, we are going to set up two settings that will help us debug this problem further. The first one is going into the settings of the React DevTools profiler. Then check record why each component rendered while profiling. And the second one is going in the performance tab and specify a performance throttling, either 4x or 6x. I suggest to do this because it makes performance problems much more explicit. And so if the interface, the UI, is snappy even with those slowdowns, it means there's a good chance it will be super snappy without them. Without further ado, let's go into the React DevTools profiler, hit record, and then select a few of those items. Now, due to the slowdown, this process will be extremely slow, but that helps us debug these things further. So after selecting a few items, we hit stop. And on the top right side, right here, you see the highlighted commits. Commits, in short, are the renders that caused the DOM to update. And as you can see, the current one took more than 2 seconds. By hovering on the various elements, you can see how much rendering time is spent on each of them. As you can see, most of the time is spent rendering all the list items, as you can see. And every time we select a new item, we still re-render the whole list. Now, for each item, we are currently spending 20 milliseconds on average. And spending 20 milliseconds on a single item is not inherently bad. As long as the entire operation takes less than 100 milliseconds, the action would still be perceived as instantaneous by the user. Our biggest problem is that selecting a single item caused all the items to be re-rendered. And that's what we are going to tackle right now. A question you should ask yourself at this point is, what's the expected number of items being re-rendered after an action? In this particular case, the answer is 1, as if we click on an item, we'll only need to update the field, the look of a single item. The other ones won't be affected. So in this case, the correct answer is we want 1 re-render for each selection. But let's say you have a list in which you can only select a single item. In that case, you expect 2 re-renders, because if I select an item, then I expect both to unselect the previous item, so updating its UI, but also selecting the new selected item. So in that case, we would expect 2 re-renders. In this case, just one. Okay, so the first thing we'll try to do right now is preventing re-renders with React.memo. Ideally, we would like to re-render only the items whose looks are affected by the new selection. And we can do that by using the React.memo higher order components. This one. In a nutshell, React.memo compares the new props with the old ones, and if they are equal, it reuses the previous render. Otherwise, if the props are different, it re-renders the component. It's important to note that the React.memo performs a shallow comparison of the props, and this must be taken into account when passing objects and methods as props. You can also override the comparison function, like this, but I would personally advise against it as it makes the code less maintainable, and we are going to talk about this later. So now that we know the basics of React.memo, we can try memoizing the item. So let's create a new component right here. So const memoized list item, which is equal to memo react of list item. Finally, we can use this memoized list item in place of the previous one. Now, we have memoized the list item. So let's go ahead and try the application. We go back to the new window, we refresh, we delete the profiler, we wait for the application to load, we hit record, and we start selecting a few items. Now, the first thing you immediately notice is that the list, unfortunately, is still slow. As you can see, we are still re-rendering all the items. Why is that happening? So if you hover on the various items, you see a very useful information. Why this render? Props changed on click. This is telling us that the particular items the list items are being re-rendered because the on-click prop has changed. As we previously discussed, React.memo does a shallow comparison of the props by default, which basically means we are calling a strict equality operator over each prop. Let's say we write the comparison operation explicitly. That will be roughly equal to something like this. You see, we are comparing the different props from the previous and the new ones using a strict equality operator. While name and selected are compared by value because they are primitive value. Name is a string and selected is a boolean. OnClick is compared by reference as it is a function. And because we are passing onClick as an anonymous closure, every time the list re-renders, then we are passing a new anonymous function to the onClick prop, and therefore we are passing a new callback function. From an equality perspective, the callback has changed, and therefore memoized list item is re-rendered. If the equality aspect is still unclear to you, let me show you a very small example. If I say true equal to true, the answer is true because those are primitive values. If I say a is equal to a, the answer again is true because we are comparing the two values by value. But if I create a closure, in this case I'll have to use parentheses. This is a closure. And if I say this closure is equal to this closure right here, the answer is false. Even though the closure are functionally equivalent, they are two different closures from the JavaScript perspective, and so the identities are different. That's exactly what's happening in this particular case. We are passing a new callback to the onClick prop, and therefore a new identity is received, and the default memo behavior is to re-render the items because the onClick right here is different. Before discussing the proposed solution, let's analyze a common anti-pattern being used in these cases. Given that, as we said, React.memo accepts a custom comparator as the second argument, we might be tempted to pass a custom comparator like our props equal we have right now, which again, as you remember, this is functionally equivalent to the default behavior of React.memo, we might be tempted to remove the onClick prop from the comparison. If you go ahead and try this approach, you'll notice the list feels snappy now. But there are a few problems. If you select multiple items, you'll notice that we really have some strange behaviors. Some items are getting unselected and sometimes random items are being selected. This is happening because the toggle item right here is not pure, as it depends on the previous value of selected. If you exclude the onClick prop check from here, then your components might receive an outdated or stale version of the callback, causing all those glitches. In this particular case, the way toggle item is implemented is not optimal, and we can easily convert it to a pure function. In fact, we are going to do so by the end of the video. But my point here is, by excluding the onClick callback from the check, you're exposing the application to subtle staleness bugs. Some might argue that as long as the onClick callback is kept pure, then this approach is perfectly acceptable. Now, I personally consider this an anti-pattern for two reasons. In complex code bases, it's relatively easy to transform a pure function into a non-pure one by mistake. And also, by writing a custom comparator, you are creating an additional maintenance burden. What if the list item at one point accepts a new prop like color? Then you'll need to update the comparison operator with something like props.color equal to next props.color. So again, it creates an additional maintenance burden. And personally, I would really like to avoid it. And again, if you forget adding the new prop you just added, you're exposing the application to subtle staleness bugs. So again, if possible, stay away from custom comparators in React.memo. Now, if the custom comparator is not advisable, what should you do? And the answer is making the callback identities stable. Our goal is to use the base version of React.memo without the custom comparator, as it is right now. Choosing this path will both improve the maintainability of the component and its robustness against future changes. For the memoization to work correctly, though, we'll need to refactor the callback to keep its identity stable. This callback right here. Otherwise, the equality check performed by React.memo will prevent the memoization. The traditional way to keep function identities stable in React is the useCallback hook. The hook accepts a function and a dependency array. And as long as the dependencies don't change, neither does the identity of the callback. So let's refactor our example to use useCallback instead. We want to extract this handler into a separate function. So we'll call it handler click useCallback from React. And then what we are going to do is call the toggle item from that we receive as prop. And we don't know yet what to put here. And then because we depend on the toggle item function, we place toggle item as a dependency. Finally, what we can do is replacing this anonymous closure with the handle click handler we just created. Now, of course, we have a problem. Previously, the anonymous function we had, this one, received the item during the iteration, and it passed it to the toggle item as an argument. But now we are not declaring the handle item handler inside the loop, so we don't have access to the item inside the handle click, at least as of now. So what we are going to do is refactoring the list item. Firstly, we change the list item to accept the item prop. And because the item itself, as we know from the beginning, contains the name, we can remove the name prop because it's now redundant. Okay, and then finally, what we do is passing the item we received as prop to the onClick callback. So we would again create an anonymous closure passing the item. As you can see, the onClick handler now provides the current item being clicked. Now, some of you might argue, hey, but you just said we shouldn't use anonymous closures inside React components. That's not correct. What I said is we shouldn't use anonymous closures inside the list iteration we are trying to optimize. There's nothing wrong, inherently wrong, in using an anonymous closure right here. Now, you could use useCallback here as well, but that wouldn't provide any benefit for this particular scenario. So in this case, let's stick to the anonymous closure because it's cleaner. So finally, we can refactor the list component because now the handle click will receive an item as argument, and we can use that argument, we can pass that argument to the toggle item function. We save it, and okay, yeah, we have a little bug because we don't have the name anymore. We can use the item and access the name from there. We save it, and if everything was right, we do have a problem. Yeah, because we didn't pass the item. So let's pass the item here. Let's have the name. Okay, so after saving, what do we have if we open the list in another tab is that the items are now working, but it's still slow. In fact, if we open up the profiler and record the selections, you can see that we are still rendering the whole list. And if we hover on one of the items, we can still see that the reason why the items are being re-rendered is that the onClick prop has changed. It means the identity of the onClick prop is not stable yet. That means the identity itself of our handleClick handler is not stable. So we'll have to work around this issue as well. Before diving into the proper solution, let's discuss another common anti-pattern used in these cases. So because useCallback accepts a dependency array, we might be tempted to remove the toggle item dependency from here. If we save it and open it up in another tab, you can see that the list feels snappy, but we are still suffering from the same stateless bugs we saw in the other anti-pattern. So why is it happening? That's happening because we are not specifying the correct dependencies here. Because the handle click depends on the toggle item method, then we must specify toggle item as a dependency. Otherwise, again, we are running the risk of using stale callbacks. In this case, it would have been a stale toggle item reference. And we are, again, exposing the application to staleness bugs. So always specify the dependencies in your useCallbacks, useEffect, and useMemo hooks, because otherwise, again, you expose yourself to a lot of tedious bugs to solve. As we previously discussed, the problem with our handle-click handler is that the toggle item dependency changes at each re-render, which in turn causes the useCallback to change the identity of handle-click as well. Our first attempt is to wrap the toggle item with another useCallback call. So we wrap it to useCallback and we specify as dependency selected because it depends on the selected state variable. So again, we save it, we try it in our example, and it's still slow. So it's not glitchy, but it's still slow. Why is it happening? Well, the problem is that our toggle item method, as it is right now, depends on the selected state variable. Every time selected changes, this identity of the toggle item changes as well. Now, if we want this identity to remain stable, we need to make toggle item a pure function. And to do that, we can use useState's functional updates. Basically, you can set a state in two ways. We can either pass the value of the actual state, or we can pass a function that accepts the previous value and computes and returns the new value based on the other one. So what we do is wrapping everything in the selected setter, which is the setter for our useState hook. And this setter gives us a parameter, prev selected, like this. And then we take the existing logic and we adapt it to the new selector. So in this case, what we do is saying, okay, the previous selected, if the previous selected doesn't include the item, then we will return a list with the newly selected item. Otherwise, we return a list without the selected item, like this. Now, because, so it is pre-selected, sorry. Because right now the toggle item does not depend on selected anymore, we can remove it from our dependency array. So, okay, so here we have to say pre-selected, sorry. Right now, the toggle item is now pure because it does not depend on anything outside its scope. If we go ahead, refresh the page and try it out, we can see that finally our list is snappy and it's not buggy. If we open up the profiler and we start recording and select a few items, what we can see is that we are now rendering only one item every time we do an action. And that's exactly what we hoped for. Our target was one re-render for each selection. So that's good. We finally got to our goal. I wanted to make another note about these functional state updates, which are critical if you want to optimize React applications. In this example, converting our toggle item function to become functional, to become pure, by using the functional mode of setState was relatively trivial. In real-world scenarios, though, things might not be as straightforward. For example, your function might depend on multiple state pieces. So let's say I create another state variable like isEnabled and set enabled, useState true, let's say, or false, let's say false. And then we only toggle the items if isEnabled, like this. So I change it, I place it here, and I say that it depends on isEnabled because it currently does. So every time isEnabled value changes, your toggle item identity will change as well. In these scenarios, you should either merge both substates into a single one so that you can use, again, the functional state updates, or even better, you can use the useReducer hook. Given that useReducer's dispatch function identity is stable, you can scale this approach to very complex states. And the same applies to, in fact, to Redux dispatch function. So if you're using Redux, you can create something like this. Say I already created this example, but let's say you are using Redux, you could write something like this. You have the dispatch function, and then the toggle function itself depends on the dispatch function, which is stable. So you could, in theory, not add it right here, but because the slinter plugin usually complains, let's make it happy by adding the dependency. And this is what you would get with a Redux type of state management. Before closing the video, I wanted to briefly cover list virtualization, a common technique used to improve performance for long lists. In a nutshell, list virtualization is based on the idea of rendering just a subset of the items in a given list, generally the currently visible ones, and deferring the rendering of the others until needed. For example, if you have a list with 1,000 items, but only 4 are currently visible at any given time, then we might only render these 4 items first, and then the others can be rendered on demand when scrolling. List virtualization offers 2 main advantages compared to rendering the whole list. We have a faster initial start time, as we only need to render a subset of the list, and we also have a lower memory usage, because only a subset of the items is being rendered at any given time. That said, list virtualization is not a silver bullet you should always use, as it increases complexity and can be glitchy. Personally, I'd avoid virtualized lists if you are only dealing with hundreds of items, as the memoization techniques we discussed in this article are often effective enough for most use cases. Now, on older mobile devices,
you might need to lower this threshold. As always, the right approach depends on the specific use case, so I highly recommend profiling your lists before deciding on any complex optimization techniques. You now have all the tools needed to profile your lists. We are definitely going to cover list virtualization in one of the future videos. If you're interested, I suggest you take a look at the React window library if you're using React for the web, and the flat list component if you're using React Native, as those are the most common ways to implement virtualized lists in React and React Native respectively.
Alright, in this video we covered list optimization in depth. We started from a problematic example and gradually solved most of the performance problems. We also discussed the main anti-patterns you should be aware of, along with potential ways to solve them. React.memo is an effective tool to mitigate performance problems, but you might need to refactor your application to make your props identities stable. If you are interested, the final code is available in a code sandbox. The link is in the video description below. If you want to practice, there's one small useMemo optimization left to add in our example. Can you spot it yourself? Let me know in the comments. Alright, that's it. Thank you very much for watching. If you liked the video, please consider leaving a like and subscribing to the channel because it really helps, and I hope to see you in the next one.